Okay, I'm gonna boldly call this lecture "Quantum Everything," and that is the idea that quantum mechanics really didn't start with Planck or Schrodinger's or Bohr or whatever. Quantized things have been in our view for since almost the beginning of time, and I mean in our view, and in the human's perception, we didn't have to create quantum mechanics in order to understand quantized entities. So I call it quantum everything because, well, let's just take Schrodinger's cat, which is one of the classic examples of quantum mechanics. You got the cat inside a box, and I don't know, you have some sort of radioactive source that shoots, once if it explodes or whatever, fissions the uranium atom, it knocks over, I don't know, a vial of poison, and the poison kills the cat. And so we can't see inside the box or measure the box in any way, and so we don't know if the cat is alive. Go look at my Schrodinger cat lectures, YouTube videos, or somebody else's. They'll explain the Schrodinger cat thing, but I think I've explained it pretty well. If you can't look inside the box, you can't know if the cat's alive or dead. So quantum mechanics that was invented in the actually this was invented around, I think, 1926 or something, 1925. Schrodinger invented this around then. This is supposed to show you what's called two wave functions, quantized wave functions. The cat is alive and dead at the exact same time. It can be in two quantized states at the same time. My point is this, and that is, I don't need anything complicated, uranium and poison, and put a cat in a box. I'm sitting over here. The cat's on the other side of the house. I don't know if the cat got hit by a car or eaten by a dog or something, so me right here, I'm already putting in the 1500s, 400 years before quantum mechanics was invented. Just to give an example, my cat already was in two quantum states. It was either alive or it was dead. I didn't know which one it was until I saw the cat. And that's the same thing that happens over here until you open the box. Schrodinger then says, then the wave function collapses, and we know now that the cat is alive or the cat is dead. And that's what it is. But that happened in in the Egyptian days, when they had cats and couldn't find them and say, this or that. The idea of this is what's called faith, in a sense, and not religious faith, but my definition of faith is what's called probabilistic analysis, and that is you just put a probability that the cat is still alive, or that your car is still in your driveway. Maybe somebody stole your car, so your car is in two different states, and it's in a stolen state and it's in a non-stolen state. It's already, or it's got a flat tire and you can't drive it to work. There are multiple wave function states that things could have been before we invented, a long time before we invented quantum mechanics, with horses. My horse is gone. Oh, I didn't know that. Well, you were doing quantum mechanics with your horse, you don't have to do it with atoms or stuff like that. The other thing is humans are quantized also. I mean, if we allow for the fact that the more complex a system is, the larger the statistical errors it might incur. What that means is people could slap me and go, no, humans aren't quantized. Some of them are born with 6 fingers, or some of them are born with only, on one hand, or some are born with only 4 fingers, or some are not born with an arm. Well, that's sure because it's a complex system. But for the most part, most humans are quantized. They're all the same. They've got the 5 fingers and 5 hands, and so do cheetahs and whatever. These things are quantized. There's one cheetah. So houses are quantized. Cars are quantized. There's not 1.5 cars. Oh yeah, there are. They're tandem bikes. Well, that's fine. But I mean, most bikes, are quantized. Even a tandem bike is one bicycle. Money is quantized for sure. There's not 1.1 cents, there's 1 cent or 5 cents. So we have quantized money, and we've had quantized money, since the Romans had shekels or whatever, thousands of years ago we've had quantized money. So, quantized whales, there's 1 whale, it's not 1.5 whales, so that's why I call this lecture Quantum Everything, is to show you that, and this can go on forever and ever, of course, with lots of different examples, of this, and then we have the other side of the other side of the coin, which quantum mechanics states like the opposite, that the electron is not one single thing. The electron is spread out. It's spread out, in its location. It's not definite. There's the Heisenberg uncertainty principle. So it's funny that on the one hand, quantum mechanics says, oh no, it's definite. There's 1 electron or whatever. And then on the other hand, the quantum mechanics says almost the same thing that we've experienced that we had before, the idea of quantized objects, and that is that things are uncertain and they're fuzzy and they're sometimes unknowable. We've had that way before quantum, and that's why sometimes when people talk about quantum mechanics and say it's bizarre and whatever, and there's certain aspects that are bizarre. On the other hand, there's many books that say quantum mechanics is a deterministic deterministic theory. You can see one of my lectures I have on that, where I quote a very reputable source, not a crazy wacko, scientist, source that's is very reputable. It's Sham's Outline Series, book on quantum mechanics. So I just wanted to show you that we have 1 star, 1 planet, 1 galaxy, and yeah, there's the weirdo 1.5 galaxies. Oh, these 2 galaxies collided and what have you. But it's funny that we look into space and we look at this beautiful quantized spiral galaxy, and nobody says, oh wow, that's interesting. It's 1 spiral galaxy. That's kind of interesting. 1 elliptical galaxy, and there's some straggler stars here and there, on the outskirts of the but most of space is empty, and that elliptical galaxy, 100 billion stars or whatever, spiral galaxy, or even maybe the non-quantum ones, which I still consider the irregular galaxies. They're fairly isolated in the universe. Okay, so I call this quantum everything. We've had quantum mechanics since humans first looked out at the world. All right, I hope you. I don't know if you understood this. This is probably one of the strangest lectures that I ever gave, but I hope you enjoyed it, and I look forward to any comments. Thank you for watching.